Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start lecture number 28, and during this lecture we will discuss two topics. One is macros and the second topic is Windows 32 console programming. Before going to start this lecture, we will revise what we did in lecture number 27th. So in lecture number 27th we discussed about two-dimensional arrays, the basic concept, what are two-dimensional arrays and so on, and how can we represent two-dimensional arrays inside the assembly language. So basically all these arrays, either one or two-dimensional arrays, they are represented in a one-dimensional memory. So there are two ways to represent two-dimensional arrays, either in row major column order or the column major order. So here you can see, as we discussed in our previous lecture, this one is the row major order and this one is the column major order. So all the rows are row wise. The first row has been stored inside the memory, and the second row and third row and so on. In the column major order, first column has been stored inside the memory, second column, third and fourth and so on. So in the linear memory, all these arrays, two-dimensional arrays, there are two ways to represent them. So inside the base plus index operand, it will add the two values of two registers. These two registers are called base and the index register. They produce the effective address. So here you can see, for example, this one is the array, and we have the offset of this array in EBX register. So this is the base address, and this one is the index address. So here we can combine. So this bracket, angle bracket, is most important. We have to use this one. So base plus index, they form the effective address, and from this address we read the word, and that word will be stored in the AX. The second example is here. You can see we are going to use the same. EDI is another register. This register is used as a base register, and the ECX is used as an index register and so on. Then the second method is called the base, index plus displacement. So these three operands are the base, index and displacement operand, adds base and index registers to a constant, and they produce the effective address. So this displacement, it can be the name of a variable or a constant, expression or so on. And the syntax for this base, index and displacement method is given here. So we use base register, the index, and then this displacement. Or sometimes we write displacement outside. So if it is a variable, for example, we write outside, then base and index we write inside the angle brackets and so on. So for example, here we have the row number and we have the column number. So how we can use table and EBX and ESI. So EBX is used as number of columns multiplied by row number, and the ESI is column number. So we can combine them and we can read this element of a two-dimensional array. Then we discussed about the structures, the way we can define a structure. So here you can see structures are nothing but the user-defined data types. They will be used as a user-defined data types. So this is the format of the structure, how we can define a structure. So name of the structure should go first, then the keyword struct, and then there are the field declarations. These are the members of this structure, and in the end we have the same name and the end as directive. So here so in the end we have the name and the end as keyword to end this structure. So here is one example. Here you can see we have defined one structure. The name of this structure is employee, and there are four fields that we declared here. ID number, that is type byte, and there are 9 bytes inside this field. Then we have last name, that is a byte, and 30 bytes are there. Then years, and then the salary history. These are the four members or the four fields inside this structure. How we can declare structures, assign values. So here there is no value, or this is called the empty or undefined or null values to all the members of this employee structure, and we define one variable, worker. This is a variable of type employee, and here you can see how we can access the members. First of all, for example, if we want to know that what is the name or what is the type of this employee, so you can see this type will give you the total size. For example, if we try to find out the type of word, then it will give you 2 in bytes, 2 bytes, and double word is 4 bytes, byte is 1 byte, and so on. Size of employee is the same, and then the size of worker, for example, if I say worker, so you can see this for size of worker is same. And if I want to access the member or the field of this structure, then I can write employee dot salary history and so on, and if I write type, then it will give the type of this member and so on. Now this was a very brief review of our previous lecture. Now what we are going to discuss during this lecture, this is the lecture outline. First we will discuss about macros, and in this topic we will discuss about what are macros, how we can define macros, and how we can invoke them. A very short or very brief overview about these macros. Then we will move towards the next topic, that is called the Windows 32 console programming. And inside this Windows 32 console programming, we will see the background information, like the what is Windows 32 console programs, what are the APIs and the SDK, what are the Windows data types, and then we will try to relate these data types with the assembly language data types and so on. Then standard console handles, and then the console input and a console output. So first we will start with the macros. So how we can introduce macro, or what is the macro? A macro is a named block of an assembly language statements. For example, if we define number of statements, so for example we have statement number 1, then we have statement number 2 and statement number 3, whatsoever the number of statements. So we give them one name, and the same block, for example, this is the name of this whole, all these 3 are multiple statements, assembly statements. And once we define these statements, once we define these macros, or this macro, it can be invoked or it can be called one or more times. So there is one specific method how we can call this one. We do not use invoke, and even we do not use call, but for these macros we just directly write the name of this macro. So you will see in the next slide how we can define the macros and how you can call them. So during the assembler's pre-processing step, each macro call is expanded into a copy of the macro. For example, where you are going to call this macro, all these statements are expanded inside the program where you call them, and the expanded code is passed to the assembly step where it is checked for the correctness. So before going to assemble this one, the whole program, it has been expanded and it has been checked for the errors and so on. So how we can define macros inside the assembly language? Here you can see a macro must be defined before it is used. So before going to use it, so for example we have the data, and then we have code. So definitely we are going to use these macros inside this code area. So we must define macros here before, and even these macros can use the data types, or can be used or can be passed parameters, whatsoever the data type or elements you are defining here. The variables are the elements you define in the data section. And the parameters, here you can see there's a macro name. So this is the name of the macro, and the keyword is macro, and it has the optional parameter list. Either you can pass parameter, either if you don't want to pass parameters, you can leave it empty and so on. And there's a statement list, and in the end, to close this body of this macro, we have the end m keyword. This end m keyword shows that this is the end of the macro. So each parameter follows the rules for identifiers, the same rules which we use for the identifiers, like how we can define identifiers, what should be their naming, and so on. So these same rules must be followed when we write some parameters, when we pass arguments, and when we pass parameters inside the macros. So it is a string that is assigned a value when the macro is invoked. So for example, when we invoke a macro, this will be considered as a string and it will hold the values and so on. So this is the syntax of the macro, and as you have seen. Now the simplest macro that we can define is clear registers, for example. Now this is the example. Here you can see complete example, and in this example you will see how we can define macro and how we can call them. The name of this macro is clear registers. You start with the macro keyword, followed by the macro keyword, and then there is an end m. So this is the definition of the macro. There are three registers that we clear the contents of register. So we use exclusive R, EAX and with itself, then EBX with itself, and ECX with itself. So clear their contents, and then inside the data section there is nothing. And in the main program, what we just write the name of this macro. You can see here. So this macro will be invoked. So the assembler, what the assembler will do, it will substitute all these instructions here at the place of this calling statement, or the calling of this, or invocation of this macro. So this area will be replaced with all these instructions inside the macro and so on. So this macro will clear the contents of 3. So you can define multiple any logic inside this macro, and that logic will be followed in the or will be substituted inside the code area or the main program. For example, we have multiple times we have used the write string, the invoke statement for the std out. And here you can see there are multiple parameters that we pass. For example, we have the std out address of the area or the buffer or the string that we are going to write down. So for example, we write invoke std out address and so on. And this is a very long instruction. If we want to make the shorter version, or if we want to write our own type, for example, our own statement. For example, here you can see write str is the macro that we are going to use, and one of the parameter is called the buffer1. And there are 3 statements. What we do, we push AD all the registers and we pop all the registers. As we know that when we write or when we read from the standard input or output, then definitely our register, their values has been changed. For example, EAX, EBX and all these registers, for example, few of them, they are not being saved by this invoke std out or std in and so on. So what we do, if we want to save them, and then we can add these 2 instructions like push AD and pop AD inside the macro. So this is very simple. For example, this is the definition of the macro. And now we invoke this one. How we can invoke? For example, str is a string variable. It's of type byte, and here is a string. Now we are going to call this or invoke this macro by writing this macro name is the write string and then the str. So when we call this or invoke this macro, it will print out whatsoever the string you want to print, and at the same time it will preserve the registers, the values of the registers after writing the before whatsoever the values of registers before the invoking or writing on the std out call or invocation, and after that the same values will be replaced inside the registers. So we can preserve the registers as well as we can perform the string writing or string printing function and so on. So here you can see at this place For example, this is statement number 1. So at this place, this code will be replaced. The name push AD will be replaced as it is invoke stdout and address. So you can see here the str will buffer 1 is replaced with the str and so on, and then pop AD. So all these 3 instructions will be replaced where you are calling the or invoking the macro. So invoking a macro, when we invoke a macro, each argument we pass, it matches a declared parameter. So it is more important. Sometimes we pass parameters which do not match with the. Sometimes we pass arguments that do not match with the parameters. So it should be you should be very much careful that what are the arguments you are passing, and what are the parameters that you have defined for the macro, and so on. And each parameter is replaced by its corresponding argument within the when the macro is expanded. So you should be careful. For example, if you have defined some parameters and you do not pass the arguments, then there will be problem. You will see in the next few slides these type of situation. So when a macro expands, it generates assembly language source code, as we have already discussed, and the arguments are treated as a simple text by the preprocessor. They are not considered as a variable and so on before assembling and linking and so on. So they will be treated as a text and so on. This one is the relationship between the macros, arguments, and the parameters. So you can see macro invocation statement. When we invoke, it passes the argument to the macro and so on, and the arguments are passed inside the macro, and they are replaced with the parameters, and these arguments consist of nothing but they are considered as a text, and these parameters are declared inside the macro and so on, and macro generates the assembly code. So this is the overall relationship between macros, arguments, and the parameters. So when we invoke, the arguments are being passed, and these arguments are replaced with the parameter, and these arguments are considered as nothing but a text, and these parameters are declared inside the macro, and macro is generated. It generates the assembly code and so on. For example, we have the write string macro. So we have, for example, if I just remove this write string, so we have, for example, write string macro. So what does this write string macro will do? It will provide a convenient way to display string by passing, as you saw in the previous example. So write string macro, and we have buffer1. So you have seen this example, and by passing the string name as an argument. So a string name has been passed as an argument, like here is buffer1, and then the str1. Okay, str. Okay. So here you will see the one example is called write string macro. This macro provides a convenient way to display a string by passing the string name as an argument. This is the same example that you have seen in the previous slides. So we are passing one argument here. So this write string macro, you can see the expanded code. The expanded code shows how the string argument is replaced by the parameter named with the buffer1. So here, when we invoke this one, and all these 3 statements are being replaced in the main program, and this buffer1 is replaced by the str. So you can see the relationship between the arguments that we pass and the parameters inside the macro. Now, as I told you in our in previous slide, that we have to be very much careful when we pass arguments inside the macros. So for example, if you pass an invalid argument, there will be an error when you expand the code. When the expanded code is being assembled, how will it generate the code? For example, we have m put character. This is one macro. Whatsoever the function of this macro is, for example, it will print the character or something, and there is one parameter that is being passed called the character char. Okay, so what we do, we push eax and then we pop EX. And here what we do, we assign this 1 byte value or 1 byte information to AL. Okay, so this is, and this AL value will be printed somewhere and so on. Inside the code, for example, we do just like we write dot code and then we call this macro here. If we call this macro input character and we are passing the argument is like 1, 2, 3, 4 hexadecimal. If we pass this one, then what will happen? Move AL 1, 2, 3, 4 hexadecimal. So this is like 16-bit, and we are passing it into the AL. So we should have to be very much careful when we are passing arguments to the macro. Here, the same example. For example, if we do not pass any argument or a blank argument, if we pass a blank argument, even then error is also caught when the expanded code is assembled. The example is we are not passing anything here. Actually, this was being replaced. The value that we passed, that was going to be assigned to AL. But here, if we write move AL comma nothing, and there is nothing there, so in this case, even you will get the errors. Now, the next topic of this lecture is the Windows 32-bit console programming. What is Windows 32 console programming? So first, there are some questions. For example, how do 32 programs handle the text input and output? You have seen the invoke, std in, std out, and so on, but how really they are being handled in the 32-bit programs? And how are the colors handled in 32-bit console mode? How are time and date they are handled in the Windows, Microsoft Windows, and so on. And how can I use MS Windows function to read and write data files? Means how can I open a file? How can I write data inside a file? How can I read data from a file, and so on? And is it possible to write a graphical Windows application in assembly language? And there are so many multiple questions. So these are very important questions that till now means we assume that this assembly language definitely it operates at the very low level. However, there are some APIs and functions that are being used inside this window or inside the assembly language to easily program for the Windows and so on. And you will see in the next few lectures how we can easily write a program to generate windows and to create windows and so on. Even then, how we can embed this assembly language inside the high-level languages and so on. So, Win32 console programs, these programs run in protected mode. So, the protected memory access mode, and they emulate the MS-DOS. So, we have the MS-DOS window, for example. So it is emulation about DOS. So we have like minimize and so on. We have this one and cross and so on. So this is the DOS window that we use inside the output window which we use when we compile our programs. So it will emulate the MS-DOS, and standard text-based input and output programs you can write it here. And the console input buffer, there are two buffers, two types of buffers which we use. One is called the console input buffer, and then console screen buffers. So there can be multiple output or screen buffers, and there's one input buffer. So the console input buffer, it contains the queue or a sequence of input records, each containing data about the input events. For example, we have, you will see in the next slide how we can define these events and so on. So we have information what you read from the keyboard. So there is some area inside the memory that is responsible to hold this data temporarily, and we can read it from there. And inside this queue, these events will be like examples of input events are like keyboard input, mouse clicks, and the user resizing our console window, resizing of the console window, and so on, and the other events inside the console programs. So this console input buffer will hold all this information or the input events in it, so that we can read it from there and we can use it in our program. On the other hand, we have the console screen buffers. There can be one buffer or multiple buffers. It's a two-dimensional array of characters and color data. So one is the character and color data that affects the appearance of the text in the console windows. For example, if you want to print anything here, any text-based output inside this window, so you can change the colors, you can change the attributes of the text, and so on. So we just divide this whole screen into multiple buffers and multiple windows and so on. You will see in the next few lectures how we can divide them. So just assume that there are, just imagine or just get an idea that there are two buffers, input buffer and a screen buffer, and we will use these two buffers when we write programs for input and output. So this input and output can be text, or input can be events of the keyboards or the mouse clicks and so on. There's a classification of the console functions. The functions that we used, the function that we will use inside the console programming or Windows 32-bit console programming. First category is called the text-oriented or high-level console functions, and the second category is event-oriented or low-level console functions. So what is in the high-level console functions? They read, for example, they read characters streams from the input buffer, write character streams to the screen buffer, and so on. So read character from the input buffer, write character streams to the screen buffer, and redirect input and output, and so on. The event-oriented or low-level console function, they retrieve keyboard and mouse events. For example, either you caps lock and all these keys if you want to monitor the status, and about the you can retrieve the keyboard, the mouse events, like if you press any key, right click, left click, and so on, and the current position of the mouse, and so on. And then you can detect user interactions with the console window. For example, if you want to minimize drag and everything, and the control window size and position and text colors. So you can, in this type of console function, event-oriented console function, you can control the size and position of the text color and so on also. There are two concepts. One is called the API and second is called the SDK. So what is API? So here we will use the Windows 32 console functions. They are defined in the Win32 API. So in the Microsoft Win32 API or application programming interface, so it's nothing but, API is nothing but a collection of types, constants, and functions. As I told you, we will use these functions, and these functions they have their data types, and these functions are using the constants and types and so on, and everything is defined inside the API. They provide a way to directly manipulate the objects through programming. So we will use API functions, Win32 API functions, to manipulate objects. What are these objects? You will see in the next slide. We have the input devices, output devices. So drivers will create objects, and we are using them to interact with these devices or hardware indirectly, and so on. And then we have the Microsoft Platform Software Development Kit, or SDK. So SDK is nothing but collection of tools, libraries, sample code, and documentation that helps programmers to create applications. This SDK, you can see, is available online. You can find the help regarding all the Microsoft tools, languages, and so on. And at the same time, there's a platform. So this platform is in a Microsoft platform. If we say there are operating system, or an operating system, or a group of closely related operating systems, The information is available online. You can see for the SDK, Microsoft SDK. It's freely available. You can explore there. Now the data types, Windows data types. Now the Windows data types, here you can see how we are going to relate these Windows data types with the MASM or macro assembler types. For example, in Windows, inside the Windows we have bool or boolean. That is, in MASM we use as a double word. Boolean value is either true or false. And byte, in this list is not the complete one. There are so many data types which are being used inside the Windows. However, we have the predefined few data types which we use in the MASM. So how we can interact them or how we can relate each other. We will discuss few of them. For example, here is a character data type inside the Windows, and we can use the same like byte data type inside the MASM. So it will define the 8-bit Windows ANSI character and so on. So color reference is the color value, a 32-bit value used as a color value, and this can be used as a double word data type inside the MASM. Double word is same as double word handle. This is more important. Handle is a data type that is being used inside the Windows, and we have the same data type is called the double word inside the assembly. So this handle to an object, just remember one thing, handle to an object. This object is more important that we will focus throughout the rest of this lecture. So handle to an object, so its type is handle. Just remember this thing. So the type is handle, and it will handle the it provides the handle to the object. Okay. Then we have h file, handled or file opened by open file, integer, long, LPRM, and so on. So all these are the multiple data types, or so many data types which are being used by the Windows, Microsoft Windows, and they have their corresponding data type inside the Microsoft MASM or macro assembler. Now what are these handles? Here you can see we have applications, and there are multiple applications here. Then we have the user mode and we have the kernel mode. So we have input output manager. So we have IOS subsystem, then we have drivers, and then we have devices. So drivers sometimes directly control the devices, sometimes we have handles, or the objects are being created by the drivers to handle the devices. So whenever you want to interact with these devices, either the input or output devices, we need these handles, or we need these handles for the objects, so that we cannot directly interact with the devices, but we interact with them through these handles. So the driver, this driver tells the IO manager, the input output manager, that for example, that here is a device for me to control. For example, there are multiple devices that this controls. If any of the requests that is being received by the IO manager, drivers will direct or assign the objects for these devices to be handled or to be communicated through these applications. So these are the handles that we are going to use. Now it just means that some new objects will be created in the memory. These are not the, so here these are not the devices, but these are the actually basically the hardware devices that we are going to deal with, for example, and these new devices or the new objects will be created to relate with these devices. So we are not directly communicating with these devices, however we are using these handles that will communicate with these devices. So we name these device, when we name them as a device object, so representing a physical or logical device on the system and describing its characteristics. So here these objects or the device objects will be created, which are called the handles, and they have all the properties, all the characteristics defined about those objects, about those devices, and we can use them. So now we will discuss about the standard console handles. So all the Win32 console functions, you will see the complete list of all those not complete list, but few of the console functions, Windows 32 console functions. And these functions, as we know that they are classified in high level and low level and so on, they interact with the devices and so on. They either we can read, we can write text and everything. They require us to pass handle as a first argument or maybe as an argument inside those functions. So all the Windows 32, most of them, not all but most of them, they require this handle to be passed. Now before going to pass this handle, what's a handle? A handle is an unsigned 32-bit integer. This handle is a 32-bit integer that uniquely identifies an object such as bitmap, drawing pen, and or any input or output device and so on. So it can be a hardware or a software object and so on. So mostly we are dealing with the hardware objects like the input output. We are dealing with the hardware devices, so it can be a mouse, it can be a keyboard, it can be a monitor and so on. So if we are dealing them, so we need one 32-bit integer which uniquely identifies that device. Identify an object that is related with this that device. Now the Microsoft Windows has constants, predefined constants, to specify the type of handle request. So we need to request the handle that, for example, if I say I want to use an input device, for example, or input buffer, whatever data comes to the input buffer or from the keyboard, for example, I want to access that area. So I will be given the handle, and this handle I will use inside other functions to interact with this device or with with that object. So if I need input handle for the input devices, then I will use std input handle. If I need the std output handle, then I will use the if I need the standard output handle, then I will use std output handle and so on. And for the standard error output, then I will use the std error and handle and so on. So the latter two, like these two handles are two constants which we request for the handles are used when writing the console's active screen buffer. For example, we have the console screen and we have active screen buffer, and we want to write some data here at this point or maybe at this point and so on. So these two will be used. And one thing you must remember here, that if you want to use, as you saw in previous slide, that we need kernel 32 include and lib and user 32-bit include and lib files if we want to use these Windows Win32 console functions. Now, for example, there is one very basic function, Win32 console function, that is called the get standard handle. So we need a handle for any device. For example, if I need the input handle or maybe the output handle, so I will define here that what type of input or what type of handle do I need. So this get standard handle will return a handle to a console stream. So it can be either input, output, or error output handle and so on. And this will specify the type of handle. As we saw in the previous slide, it can be input, output, error and so on. And the handle is returned inside the EAX register. So for example, if we receive a handle, first we request the type of handle that we need, then we get this handle, or we will receive this handle inside the EAX. Now we have to store that handle in some variable, so that in future in the next statements, assembly statements, we can use that handle. For example, the prototype is, so get standard handle, the prototype is there is only one parameter that's called the and std handle or the double word. So handle type we have to use. This is one of the very best examples. So what we write, we invoke this function, and this is the name of the function, and then we have the std output handle. So we are requesting for the standard output handle. This standard output handle we are requesting, it will be given or it will be assigned into the EAX. Now, as we know that EAX is a very general, very common register that is being manipulated by that is being used by the microprocessor. So what we do, we just move that value of this handle inside any variable and so on, so that it should be there, and then we can use it in future. So we are requesting for the we are requesting for the output handle. It will be given to the EAX or assigned to the EAX. If it fails, then definitely it will give you the error or the error handle and so on. Now these are the Win32 console functions. Here you can see, for example, here we have used one of this function here when we call invoke exit process, and we pass value 0 or null constant here. So it will end the program or exit all the threads or processes and all its threads and transfer controls to the main program. So we have, for example, we use read console, console input, console output, read console output, and so on. There are multiple functions. So for example, read console reads a character input from a console input buffer and removes it from the buffer. So once we read, it has been removed. Read console input reads data from the console input buffer and removes it from the buffer. So multiple 32 console functions, they have multiple functions, So these there are different, there are many Win32 console functions, and they have their varying functionality. So here is the read console output. So it reads the character and the color attributes data from a rectangular block of a character cells in the console and screen buffer and so on. So you can see that we can read data from the whatsoever is written on the screen. So from that buffer we can read data and so on. So the list is very long. So all these functions, they accept the device, not the driver, handles as an argument. So we need handles, as we told, as we saw in our previous slide. We request for the handle. So if once we get the handle, then most of these functions, they need that handle to interact with the devices and so on. So console input, if we want to receive input from the keyboard, for example. So we have one function, Win32 console function, that is called the read console function. So this read console function provides a convenient way to read text input and put it inside the buffer. Now how you can see the prototype. Here it needs a handle. So input handle that we reserved or which we got, it should be provided here. Then we have the buffer or pointer to the buffer where we want to store or where the data will be stored. Maximum bytes, how many bytes, number of bytes or number of characters to read from that buffer. So we need the buffer area where information will be stored. We need the maximum number of bytes, and also we need the pointer to the number of bytes read, that how many number of bytes we read from the pointer to the number of bytes that we read that are being read. Here you can see the prototype. Here we have the console, read console, we have prototype. Handle, we need handle that we request for this specific input function or input to interact with the input device, either the keyboard or and so on. And then we need the buffer area are pointed to the buffer area where you will store or where you will transfer these values or the characters that you are reading from the input and so on. How many bytes or number of characters that you want to read or that you will read, and we need also the pointer to the number of bytes we read. And unused double word is there. So in most of the functions or Win32 console functions, we have unused double word, so you can assign it as a 0, for example. This one is the example. Here you can see if we want to read single character input. If we want to read one character only, here is how one or input single character works. For example, first what we do, we get a copy of the current console flags by calling the get console mode, and we save flags inside a variable. Then what we do, we change the console flags by calling the set console mode. Then we have input character by calling the read console, for example. So then we have the input a character by calling the read console, and in the end what we will do, we set the console mode. So this is another way you can read a single character. You will see another example where we have multiple characters you can read. So first thing is you can save the flags in a variable, set the mode. So first, whatsoever the control mode is, we just save it, and then we just change this console mode. We read characters or read from this input buffer, and then in the end we just change or set this console mode according to the whatsoever the previous mode was there. So there is one read character function which is already defined in the Irwin library, Irwin 32 library inside the book, and the reference book that you will see in the end of this presentation. So that it has its own library of functions. One of its function is called read character. So how does this read character function work? For example, we have a console handle, this double word, and we have saved flags. So what we do, first of all, this is the backup copy where we save the flags, and then again what we will do, we will just try to assign these flags to the select the console mode, read data, read character, and then set the console mode. So first we get the console mode. What is the console mode? So get and save the current console mode flags. So the console mode handle is here, and then the address of the flags. So here whatsoever the flags or console mode flags are, they will be stored here, and we clear all console mode flags, and then we read the character. You can see in the next slide, here is the read character. So first of all, this is the console handle that is for the input. So console input handle, then address of the buffer, pointer to the buffer where your data will be stored, how many characters you are reading, and the how many bytes have been written, the number of bytes that you have read, and so on. So in this way, we just read character 1, and then in the end, what we'll do, we reset we restore the previous flags and so on. So this is the one of the simple function or the Win32 function, console function that we are using here. The next example is we read multiple characters. For example, if we want to read one complete line from the keyboard, and until and unless you don't press enter and so on, so it will continuously read all the information, and it will store all the information inside the buffer and so on. This is one very basic example. Here we have buffer, and we have byte, and we have buffer size. As you know, that buffer size we have already defined here. So buffer size is 80, and we have all the 80 characters, 80 characters or 80 bytes reserved here, and we have 2 extra bytes here, so 82 in total. And then we have one data type is called the handle data type. So this variable, the name of this variable is std in handle. This is our own defined or our on variable. Its type is handle type. So it will store the handle that we receive, that will get from the get standard handle and so on. So here use this statement when we'll start here, and this is the bytes read, how many bytes we read from there. So first of all, we request we get the standard handle. What type of handle we need if we want to read character? If we want to read character, what type of handle do we need? So we need the std input handle, and this std, if this instruction has successfully completed its execution, then the handle should be inside the EAX register. So inside the EAX register we have got the handle, and this handle is an object that will control the devices. So we have the handle or the unique 32-bit number that defines or that identifies an object that has the properties of this device. So this number is inside the 32-bit number is inside the EAX. Now this EAX we are going to store in the std in handle. Yes, we already stored EAX inside this one. Now what we are going to do, we have to wait for the time until someone presses, someone types something and press the enter key and so on. And at this point we use the read console, the same one which we have used in our previous example, to read one character, but now we want to read, for example, one complete line or maybe the 80 characters, for example. So what we do, we use invoke read console. This is the Win32 console function, and this is the handle. This handle should be provided in these functions so that to interact with the device and so on, and address of the buffer where your data will be stored, and buffer size. This is the buffer size, how many characters you want to read. For example, it is 80 that you want to read, and how many characters actually have been read from from the input buffer and so on. And this is not used or unused, so it is already 0. So when this instruction will be invoked, what will happen? Computer or on the console screen, there will be cursor, it will be waiting for you to type something. So whatever the current cursor position is there, it will wait for you to press something or type something. So when you will type something, you will receive data, or you will receive all these characters inside the buffer, or this variable named the buffer here. So all these characters are here inside the buffer, along with the carriage return in line with 0D hexadecimal and 0A hexadecimal. So all these two, because when you press enter, so carriage return in line feed, they will be also part of this buffer, 80 characters and so on. So for example, if I want to print what you have typed, so simply if I want to write like as in the previous lectures we have seen that if we use the std out, invoke std out and address of this buffer, so you will see whatsoever you have typed. And for example, if I want to see what are the other parameters, the values inside the other parameters, so if I want to see the offset of this buffer, so in the ESI, so ESI will hold the starting address of this buffer where whole information, a whole stream of characters from the input device have been stored. If I want to know how many bytes have been read, this information is inside the bytes read, so I will transfer into ECX. Or if you want to print them, then you can convert this double word to A, DWA to A. You can invoke this one to some string, and you can print out that one also. And you can see the type of the buffer, so you will see what type of buffer is that one. Definitely you will see the output in the EBX and so on. And this one is the exit process. This exit process, as I told you, we are continuously using since the first program in our assembly language during this course. So this is one of the Win32 console functions This is nothing but only one parameter is called the 0. It will close all the threads and the everything and returns back control back to the main Windows and or the operating system. So here it will wait for you, this program will wait for you until you press or you type 80 characters and so on. There are two structures. Sometimes in some libraries these two structures are part, or some APIs these two structures are already defined. However, most of the time in the coming lectures or maybe in the next lecture we will use these structures. One is called the coordinate structure and second one is called the small rectangular structure. So coordinate structure specifies X and Y screen coordinates. As we saw in our previous lecture also, we have used this structure, we have defined this structure. We will define the X and Y screen coordinates in character measurements with the default, which default to the 0 to 79 columns and 0 to 25 rows. This is the default values we will use in X and Y and so on. And the small rectangular structure specifies the Windows location and a character measurement and so on. So we will use left, top, right, bottom. We have whole screen, console window. If we want to perform operations on some part of this one, so we can use that one also. So these are the two small rectangular, small rect structure and coordinate structure. Now here you can see there is another function, a Win32 console function that is called the write console function. Now before going to discuss everything here, one thing you must be very much clear that we must need output handle, std output handle. So because we want to interact with the output device, so that for that reason we need output handle. And when a 32-bit integer or 32-bit value has been assigned, or that handle has been assigned or returned back by the function get handle and so on, then we can use that handle inside this write console, and we can send other parameters that what we want to write and how we want to write and what are the other parameters. So write console function writes a string to the screen using the console output mode or console output handle. You can see the console output handle will be used to write data on the screen. It acts upon the standard ASCII control characters such as tab, character return, line feed and so on. So whatsoever you are going to print, you can define the ASCII type and you can print it on the screen. Now here this is the prototype or the syntax of this write console. First thing, we need a handle. First we have to request the output handle. It will use the output handle, so we need output handle or a number that uniquely 32-bit number that uniquely identifies the object that is dealing or that is interacting with the device, output device. Then we need the pointer to the buffer where we want to write. So what information we want to write? So we need the buffer or pointer to the buffer, that is the pointer of type byte, or the information that we want to write on the screen. And next we need the size of this buffer, what is the total size of this buffer that we are writing, and then we need the count or output count, how much information has been written on the screen and so on. And this is the reserved one, so not used, so it will always be 0. In this example here we have and L. Inside this data you can see we have defined and L, and character return and line feed, they have been assigned the name and L. So we've defined one this end of the line sequence. Then the message that we want to print. So message is label byte, and this is the complete message. So this program is a simple demonstration of console mode and output and so on up to here, and then end L. This one is also assigned at the end of this string and so on, the message variable. After this one we have the message size. So message size is double word, and this is it will return or give you the complete message size in terms of number of characters and so on. And we need the console handle. We need the console handle to the output device, and then so here we assign value 0 for example right now, but we will receive some value from the get standard handle and so on, and that will be stored inside this console handle, and this console handle will be used inside the write console function and so on. Then bytes will be written. This will be returned by this function, how many bytes have been written and so on. So here first of all, at the starting point, what you have to do, we have to read, or we have to get the console output handle. We need the std output handle. So this we are requesting, and we are invoking the get std handle. So we have to get the console output handle. So if we receive, this function has successfully completed its execution, then definitely EAX will hold the standard output handle value. So what we do, we store this standard output handle inside the console handle variable. So this 32-bit value is stored here inside this variable and so on. Now what we have to do, we have to invoke this write console function, write console win32 console function, and inside this one, first of all, the first parameter is the console means output handle that we have to use, that we got there, and then the message or the address of the buffer or the pointer to the buffer that we want to print, and the size of the string length that we want to print, and then it will return that how many bytes have been written on the screen and so on. This is unused, so we use or assign the value 0. So this whole function will print the message or the buffer at this area, these characters or the area which is assigned to the message variable. All these characters are all these bytes. So we have to define the size, so whatsoever the size, how many bytes we want to print. And you can see that every console output or every win32 console function, it must need handle to perform action, to interact with the drivers, with the device. Now this is the write console output character. So what is this one? This function, write console output character function, copies an array of characters to the consecutive cells of the console screen buffer. So inside the output buffer, we just copy the values of an array, byte array of characters or byte array inside the output buffer, beginning at the specified location. So we have to define the specific location where the information will be written. So here is the write console output character. So this is the prototype, and first is the handle. So we need the console output handle as we saw in the previous example. So we need the pointer to the buffer that we want to write there. There is the size, and we need the coordinate or the first cell coordinates where we want to write or where we want to write the information. So here you can see here this coordinate, COORD, or coordinate is the structure that we have already defined. Okay, and then we have the P count or the output count, that how many has been written. So now we are going to summarize what we discussed in this lecture. In this lecture, we discuss about the macros, how we can use or introduce the macros, how we can define macros, and how we can invoke macros. So as we have seen that macro is nothing but we assign a single name, starting with the name of the macro, then we have the keyword macro and name and so on. There are multiple statements inside this macro, and we have the AND macro and so on. So we declare or define macro, and we invoke macro. We can invoke macro by calling the name of this macro. For example, if I say name of the macro is ABC, and in the program if I write ABC, then all the statements will be replaced at the place of this macro name and so on. So this is the way you can call them. And then also we discussed the argument passing and the relationship between arguments and the parameters inside the macros. Then we also discussed about the Windows 32 console programming. So in Windows 32 console programs, we saw that what are the Windows 32 console programs, what are the APIs and SDK. So we are using the Win32 APIs, and we have the Win32 console functions, which are part of the API. And we have also seen that relationship between the Windows data types and the how we can relate them with the data types in the assembly and so on. And we have seen about the standard console handles, which we can use to request for the handles or the console handles and so on. So at the time we also saw that the console input handles, and we saw a few examples of console output handles, how we can read characters from the input buffer. So before going to read characters from the input buffer, we need the console, we need the handle. So handle is nothing but 32-bit value that uniquely identifies the object that has been created to handle the device. And at the same time, we need the to interact with the output devices or any of the devices. We need these handles, and these handles are used in the console functions to interact with these devices and so on. So this is overall discussion, overall summary of this whole discussion, what we discussed in this lecture. And this is end of the lecture 28th, and inshallah hope to see you in the next lecture. Till that lecture, Allah Hafiz.